in 3, 2, 1. This video is going to look at, or start at least looking at, the allocation of credit. Who do you give credit to? Very important. If two people work on a study and one person doesn't cite the other person, that can be a severe ethical lapse. Now, the basic advice is give credit to whom credit is due. That's pretty broad. Obviously, you should try to give credit to whom credit is due. The real problem is, to whom is it due? Who should you give it to? So here is a screenshot of an article I did, the first page of an article. Renita Coleman and Stephen Banning, we used to do some research together. She's now at the University of Austin, Texas. This is Network TV News, Affective Framing of the Presidential Candidates, Evidence of a Second-Level Agenda-Setting Effect Through Visual Framing. So we were both on this, and she had originally thought of the idea, so I agreed to be second author on that, and that's how we decided on that. Now, in the standard scientific paper, like this is, credit is given in 3 places. One in the list of authors, such as I just showed you. 2 in the acknowledgments, where it says, I would like to acknowledge this person who researched my work, and maybe this and this person who helped with something else. So that's the second place. In the acknowledgments of contributions from others. And 3 in the list of references or citations. So if somebody has done some research, that those citations and references is recognizing their work. Now, conflicts over proper attribution can arise in any of these places. Sometimes I look at if it's a third-person effect article, I'll look, and if they have an idea, one of the things that I came up with, and they don't cite me, that doesn't make me too happy, because there's certain things that different people have come up with, not earth-shaking, things that don't change the world, but you kind of want to be recognized for an idea you came up with. All scientific results must be treated, in regard to error and negligence in science, as susceptible to error. All scientific results must be treated as susceptible to error. Some error could have come in there. Now, sometimes it is done a lot of studies, a lot of replications. The probability of error is pretty small. But people, especially when there's something new in research, people are a little skeptical of that. And that's scientific, that's normal. So one of the things you never say in an experiment is that the experiment proved a hypothesis. That's considered an amateur error, a rookie mistake. Every once in a while, I'll get a researcher, I'll be reviewing for a journal, and they will say, experiment proved a hypothesis, and I know this is not a professional level article. So hypotheses are supported or not supported. So you either find support for the hypothesis or you don't find support. But if you find support for your hypothesis, it doesn't mean the research, the experiment, proved what you were saying. It just supported it. So that's the proper way to look at that. In non-academic journals, people say something proved, an experiment proved this or that. It's not technically accurate, but it's pretty common. But in academic research, you don't want to do that. People will, you lose credibility. Now, what about misconduct in science? We've been talking about different kinds of things, and here we have a picture of a referee. Misconduct, both hands on hips. But how does that happen in academic research? There's 3 kinds of deception. Now, we were talking about accidents, people just were sloppy. Those are not, that's not official misconduct, but there are 3 kinds of deception. The one is making up data or results. I don't know anybody who has done that. I haven't seen a situation, but I've read news reports that people have made up data instead of just collecting it. There was one famous researcher a number of years ago, and he had done 60 or so research experiments. Somebody looked at his database, and they had read one of his other experiments, and the databases were exactly the same. You just cut and pasted the database and made up the results. That would be fabrication. You're making stuff up out of whole cloth. Changing or misreporting data or results. This is known as falsification. In other words, maybe a few numbers are changed. Data is misreported in order to make your hypothesis come through. And finally, using the ideas or words of another person without giving appropriate credit, which is plagiarism. And actually, I've seen a lot of plagiarism actually in professional circles, and in time, sometimes people have gotten, whoa, it's not over yet. Go back. There we are. I was pounding the table for emphasis, and I accidentally hit my computer. So plagiarism is definitely something you want to avoid. It can. I detected it one time when I was reviewing a paper a few years back. I saw something and I thought, I am sure that this has been done in another research paper. So I looked it up, and eventually I was able to find it. And I wrote to the editor and I said, I don't know what's going on here, but this is exactly the same as what was done in this other published research. And they actually, when they published it, they said they published something with it. I thought they weren't going to publish it, but they did publish it and say, this has been, one of these things has been published previously. And I think if I was that person, I don't know. I think that they said they didn't understand what they were supposed to do, but they were prominent enough, I suspect they did.